All right, so I've just given you the next homework assignment. You've got some time for that one. It's not actually due until Thursday, February 2nd. So we're going to be talking about the Casio calculator for a while. Please remember that you need to attach a cover page for your homework assignments. It's strongly preferred that you use the engineering computation paper, and you should have your work all stapled together before you come to class, so that we can just save as much time as possible that way. Also, on Tuesday of next week, be sure to have the calculator with you because that's going to be a requirement for attendance credit on Tuesday. I'm going to use the assignments for attendance credit, so if you're here today but didn't turn in an assignment, you need to put your name on a piece of paper and bring that to me at the end of class today, just so that I can record your name in the grade book. All right, so we're going to start talking about the calculators today. Any announcements related questions before we start that? Okay, well, here it is, the Casio fx-115ES Plus. Now, I heard another faculty member said that a student got theirs for something like $7 or $8, which I was surprised to hear it that cheap. So anybody get theirs for less than $10? Must have been somebody in the other section. How much were yours? 13, 15, okay. And is it available for sale at like Walmart, Amazon, probably the bookstore? Well, it's not my favorite calculator. My favorite calculator is an HP, but it's a pretty good calculator for the money. It does a lot, and it's on that approved list of calculators that can be used for the FE exam, and so that's one of the primary reasons that this is the one that's been selected for this course. Some of the things it can do that's kind of nice is that they have some of the formulas that are, they call it natural display, where you can type the equation in a similar way that you'd have it written on the paper. One of the other advantages of it is it can do matrices and calculations related to vectors. We're just going to scratch the surface for some of the functions that it's able to do. I'm going to post the reference manual on our website, our course website, and so that if you lost yours, it didn't come with one, you've got that available. So just check online if you ever need to remember how to do something but can't quite figure it out. The manual's nice because it will tell you individual keystrokes that you should press in order to get operations that you may need to do. It doesn't just explain it, it actually tells you which buttons to press. It also does conversions between traditional and SI units, and some of those conversions are in the homework assignment that I've just handed out, this homework 2. We're going to learn about those today, and we're also going to learn about how you can use it to display different significant figures, and so it's a matter of like the accuracy. It has a memory where you can write your own equations and have them stored in the memory. And that's not something that we'll get into, but when you get later on down the road into structural engineering or fluid mechanics, there may be equations you use over and over again that you don't want to have to type each time. And so it's kind of nice to have these pre-existing formulas built into the memory. All right, so everybody take out your calculator. The first thing we're going to do is reset it to the factory settings just to make sure that we're all on the same page, because there's a lot of strange settings that you can, for example, have the angles set to radians instead of degrees, or just a lot of custom functions that we want to make sure we're all doing the same thing. And so to clear the memory on your calculator, turn it on, first of all, pressing the on button, and then Shift 9. It gives you the menu. It's asking if you should clear. Press number 3 to clear everything, and then it asks for a confirmation, and you should press the equal button. And then you press the AC button, and it resets everything back to its original settings. And so let me just show on the emulator here what we did again. Okay, so Shift 9, clear, select 3 for everything. And it wants to confirm that with the equals, and then AC to reset all. All right, now you'll notice that what it's saying is that the angles that you put in are going to be in degrees. And then here where it says math, that's a display setting. There's a couple of different options for how numbers are displayed on the screen. And let's talk about that, those two different methods. One is called the math IO, and it will have numbers so that the fractions are actually shown as fractions on the screen. And line IO is a way of trying to compress more information into fewer numbers of lines on the screen. And so fractions look a little bit odd when you're in line IO method. So just to demonstrate, if we're in math IO format, then you can add fractions together, and this is the result you'll get. And so let's try that. Your default right now is math. So type into the calculator 4 divided by 5 plus 2 divided by 3. And this is the result that comes out of it. Now, you may be thinking that you'd rather see it as a decimal, and I'll show you how you can have it change from fractions into decimal view just in a subsequent slide. But if we were line IO format, we can go in here and change to the line IO. It's shift mode to switch between the two. So we'll clear this, and if we go into shift and then push the mode button, the option 1 is the math IO, which is the default, and option 2 is the line IO. So I'm going to switch to option 2 and then do that same calculation that we just did. I don't know what that. All right, so the same calculation where we have 4 divided by 5 plus 2 divided by 3, and then the solution, oh, well, odd. Yeah, I was doing this before class with my calculator, and it seems like maybe the emulator set up a little bit different than the physical calculator. Who's getting when they type in the numbers to actually show up as fractions rather than 4 divided by 5? Has anybody followed along and do 4 divided by 5? For it to show up? Great. All right, so he pointed out that this fraction button here toggles between the display. Now I'm back into line IO, so let's do shift mode and go to the math. Okay, so we're in math mode now. So 4 divided by 5, I guess the divided by is redundant. 4 divided by 5 plus 2, oh, gotta go back. Let's see. 2 divided by 3 equals, all right, 22/15. Now, this S to D button is what we can use to toggle between fractions and the decimal. So right now, the resultant answer would be 1.4666. Now, in line IO format, it's trying to save a bit of space, so shift mode, we go to line IO format. So 4 divided by 5 plus 2 divided by 3. Well, the emulator puzzles me because when I'm doing it on here in line IO, shift mode to switch between it, then immediately as I start typing 4 divided by 5, it's showing up like here. Into the display mode. All right. So 4 divided by 5 plus 2 divided by 3. Sounds like you guys have some previous experience using this calculator. No? Learn your quick studies. That's great. All right, so 22 divided by 15. I can't really imagine a situation where you'll want your data to be shown as this, but in case it's ever in that mode, now you know how to switch it out. You can go to shift mode and back to the math IO, which I think is probably makes the most sense for the types of calculations that you're going to be doing. All right. Degrees, radians, and gradians are something that may come up depending on what math class you're in, and you can, in the setup, the same shift mode, switch between them. So let's try that just to demonstrate what it shows on the screen. Right now it's in degree mode, so if you go to shift mode and choose radians, then now it says R instead of D. And the reason why that would maybe be important is if you're doing cosine of angles. If you did in radians mode, cosine of 45 would give you something unexpected. You'd say, well, wait, I know the cosine of 45, it's not quite that. So if you shift back into degrees mode and clear it, and now try cosine of 45 and find the number of that, 0.707. That's obviously the cosine of 45. And so if, sometimes you do need to be in radians mode when you're working in terms of radians, and of course there are 2 pi radians in a complete 360-degree circle. Gradians, I can't remember the last time I worked in gradians, but degrees and radians, you may need to know how to switch between them, so it's just shift mode to do that. Was there a question in the back? No? All right. Now, you can also have the calculator do the rounding off for you. By default, it's going to, when you press the S to D button, it'll show 9 digits of accuracy. So try 4.52 divided by pi. And pi is shift, and then down here on the bottom at the center is how you can get the pi number. And you press enter. So by default, it's going to show 9 digits there. And so let me show on the emulator how we do that. So I'm going to make sure I'm in Math IO. Okay. So we did 4.52 divided by pi, which is shift, and you can see it in the light brown down here, divided by pi equals 1.438, and so on. Now, you can change how many digits are shown by toggling between the fix and the scientific. And so back here to shift mode, fix and scientific. Fix is where you can tell it how many digits you want it to display. And so right now it's asking, you can put between 0 and 9. If we wanted to display that to 3 digits, then here it's rounding off 3 decimal points. After the decimal point, 3 additional digits are shown. Or we could go shift mode, fix, and we could have it even round to just 1, so then it's 1.4. All right, so I'm going to go back to shift mode, and most of the time you'll want fix to be showing all of the digits. And scientific allows you to get into the scientific notation. So if you wanted this to be expressed in scientific notation, then you do shift mode, scientific, and then the number of digits you'd like to see. So now it's rounding off to 3. All right. So any questions about that? All right, let's try it out. Now with your calculators, go into fix mode and do the operations that are shown here. And if you are showing, for example, 1, 2, 3 digits, you'll be able to see the 5. If you're showing 3 digits, you'll be able to see the 1. But then if you do 5 divided by 100,000, it's going to round that off to 0. And so it'll appear as though the answer to that is 0. And then do the same thing with scientific notation by toggling into shift mode, option 7, and answering the question that you want it to show 3 digits. So I'm sorry, this is going to be 2 digits after the decimal point, but 3 significant figures total. I don't see very many people punching buttons. Everybody have their calculators today? No? Yes? Okay. If you don't have one yet, it's past time to get one. And you definitely need to have it for Tuesday, next class. So you'll see it's doing the 3 digits, but if we now have 5 divided by 10,000, can do that just fine. It's showing us the answer to that, but you have to be a little bit careful because it can make numbers disappear by rounding. So 5 divided by 100,000, and it's going to round that to 0 just because of the number of digits that are shown. But if we change it in the modes to show all of them back to 9, then that same 5 divided by 100,000, you'll actually see the answer. And then we can switch to scientific, shift, mode, scientific. And let's just try this bottom one here. Let's have it do 3 digits. All right, so 5 times 300,000, 1.50 times 10 to the, I think maybe that must mean divided by if it's going to have 10 to the minus 5. Can't change it now. All right, so let's try the one in the middle. 5 divided by 1 times 10 to the 4th. So 1 times 10 to the 4th. And so 10 to the power of 4. Oh, the minus. Okay, 5 divided by 1 times 10 to the power of 4. I have a feeling that's not going to work. Let's try again. All right, 5 divided by 1, parentheses, times 10 to the power of 4. All right, now it worked. 5 times 10 to the minus 4th. All right, so we can switch between the fixed notation and scientific. So just as practice, I'd like you to try this. Here's the formula for the area of a circle based on diameter. And let's say that we have a circle that has a diameter of 6. Use the calculator to calculate the area, and when you first do that, by default, it may express your answer in terms of pi. And so if you press the S to D button, it will convert it from in terms of pi to an actual decimal answer. And then go into shift mode and change it so it's displaying it to 4 decimal points. And then also toggle shift mode to have it show the answer in scientific notation to 6 decimal points. All right? So I'll pause the recording. We've got a few minutes for you to try that out just to get practice with the new calculator. T squared divided by 4. So the first thing it'll say is 9 pi for the answer, and you click the S to D button, and then, well, I'm still in scientific notation, so it's saying 2.83 times 10 to the first power. Let me switch it back to the standard fixed notation where it's showing all of the digits. And so it'll say 28.274. And if I want to fix it so that it's only showing 4 decimal points, shift, mode, fix, and 4. So you press that, and now it's showing the 4 decimal points, or back into scientific, which is where we were just a moment ago, scientific with 6 decimal points. All right. So, pretty easy. Now, you're going to develop a fluency with this calculator that will probably persist with you for the rest of your life, and that's part of the reason why I find the Casio is a little bit awkward, is that when I was a freshman, I went to the bookstore and bought an HP, and so just instinctively I press all the buttons. I have a pattern of where I'm expecting them to be anytime I start to do calculations. And the manual is available online. I'm going to post it on MU Online. You're going to be using it a lot, and we're not going to go through every operation, but there are some pretty interesting capabilities it can do. One of the things it has is if you take the plastic cover off, you'll notice that there's some writing on the inside of the cover. And these are scientific constants that are built into the calculator, and also some conversions that it can do. And the way that you access them, as it's shown there, Shift 7 for the constants and Shift 8 for some of the built-in conversions. So let's try those. Let's try the constants. One of the constants that it has built in is Avogadro's number. And that's constant 24, where it says Na, that means the number for Avogadro. So let's say, thinking in terms of a chemistry problem here, you've got the molecular weight of sodium chloride is 58.44 grams per mole. And if you have 3.74 grams of sodium chloride, how many sodium atoms are present? And just as a refresher, if there is, the sodium chloride is 3.74 grams of sodium chloride, and it is 58.44 grams of sodium chloride per mole, then this will allow us to calculate the number of moles. Okay, so let's switch to the emulator here. I'm going to put it back into fixed mode where it's showing all 9. Clear it. All right, so we're going to try and use the built-in, first of all, we want to find out the number of moles, and then we'll use the converter that it's got. So 3.74 divided by 58.44. So now this is telling us the number of moles. Now we want to multiply that by Avogadro's number, because what Avogadro's number is, that constant is how many particles there are per mole. And so it will give us the number of atoms of sodium present in this many moles. So we want to multiply this answer. So if you multiply, it says the answer, the previously computed answer, and now we want to pull up that constant. So we'll do Shift 7 and type in the constant number, and in our case that's constant number 24. So the answer times Na and equals, so that tells us there's 3.854 times 10 to the 22nd sodium atoms that are present. All right, so most of the constants on there are related to electricity, magnetism. It's a lot of electrical engineering stuff in these constants. The only other exception that jumped out at me was that the gravitational acceleration is built in as well, g. So that one is useful, but it's also pretty easy to remember g. You know, it's 9.81 in meters per second, 32.2 in terms of feet per second. Let's try out the conversion and the constants at the same time. So if you do Shift 7 to get into the constants and then type in constant 35, constant 35 is gravity, and then enter, it gives you gravity in meters per second squared. But you can convert it to feet per second squared by doing now Shift 8 is the units conversion. So Shift 8, and if you look on the back of your case, it says that if you want to convert from meters into feet, look for that one, meters to feet, that's unit conversion number 04. So type in 04 and enter, and then what it's converted is it's converted the 9.81 into 32.2. So let me demonstrate that on the emulator. Okay. So first of all, we'll pull up the constants, and we want constant 35, which is g in SI terms, and then we can convert it by doing Shift 8. These are the units conversions, and it's unit conversion 4 to go from meters to feet. So 04. The answer in meters into feet, so enter, and now it's 32.2. So that's pretty handy. Let's do the second one of these example here. So here's a trail race that has 6,100 meters of vertical ascent. How many feet is that? Okay, so type in your 6,100, and we want to convert meters to feet, which is the one that we just did. So Shift 8 to get into the conversions, and 04 will tell you that it's 20,000 feet. Okay, so convert 6,100 meters into feet by Shift 8, 04, 20,000 feet of elevation. What about pressure? So look on the back of your case, and we want to convert 101.325 kPa into PSI. So if you look on here, kPa to PSI, which stands for pounds force per square inch, that's conversion 36. Okay, so 101.325 kPa. So Shift 8 gets us into the conversions, and it's conversion 36. That's going to do kPa into pounds per square inch. Now it looks like it's just saying 25 kPa, but I think it's because it couldn't show all of the digits that we had typed in before. So if we do enter, now we can see it's 101.325 kPa into 14.7 pounds force per square inch. So that's standard pressure in traditional units. You've got a lot of those to do on the homework assignment, but you just saw how quick they are. It's pretty easy. I wanted to mention on this assignment, you don't need to necessarily round off to the same number of digits that are provided on the beginning. So where it says 9 inches, don't just round to the nearest centimeter. Go ahead and show some of the actual digits afterwards, just so that we can be sure that you did the conversion correctly. In other words, assume that it's exactly 9 inches, and assume that it's exactly 623 miles when you're doing that first problem on the handout. Any questions on the units conversion in the calculator? All right. One of the interesting things it can do is convert between the rectangular and polar coordinate systems. And as a reminder, the rectangular coordinate system is where you're given an x and y value in order to define a point in a x and y coordinate system. Whereas polar will express the length of a line from the origin and then the angle according to an axis that's been defined, in this case the x-axis. So as an illustration, if we wanted to convert the square root of 2 for our x distance and the square root of 2 for our y distance into polar coordinates, we can go through the keystrokes that are shown here. So let's try that. We want to, first of all, I'm going to make sure I've got it in degrees and it's fixed math. Okay, so everything's fine. So I'm going to do the shift plus. And shift plus, like, you may be wondering, how are you going to remember that it's shift plus for that? Well, the shift has the brown color, and then the plus, the brown color above that says polar. So what that reminds you is that you're converting into the polar coordinates. So converting into polar coordinates, and what we want to have is the square root of 2 as our first, and have to go use this arrow key to get out from underneath the square root, and then a comma. So the comma button is here. It's the brown, close parentheses to get the comma, and then the square root of 2 for our y coordinates. And once we're out, we can do enter. It tells us the length of the line is 2, and the angle that it's going to make with the x-axis is 45 degrees. Okay? And we can convert it, we can go the other way around. If we want to convert a line that is square root of 2 is the length and 45 degrees into rectangular coordinates, we're going to do shift minus. And the way you can remember that is here in brown it's saying rectangular. So you're converting into rectangular coordinates. So what that means is you need to enter polar coordinates. So our first entry is going to be the length of the line, which in this illustration is the square root of 2 is the length of our line. Use the arrow button to get out from underneath there. We have to put in the comma button, so shift, close parentheses for the comma. And then our angle is 45, and since it's the D here, that's telling you degrees. And then equals, and the rectangular coordinates are 1, 1 for that. Okay, so try it out for this one. Oops. Really not the most convenient location for that. Oh, there we go. Try and convert from these rectangular coordinates into polar. So here's just an illustration that should give you an idea. If you did it right, the angle should be, it looks like, less than 45 degrees just by visual inspection. Good. If you've already done the polar one, then you can do now the rectangular problem. I'm going to demonstrate the polar one to begin. So we want to go into polar from rectangular, so 1.75, comma 1. It's The length of it is 2.01, and if you scroll sideways, then you can see the angle is 29.7 degrees. Sometimes the result is too long to be displayed all at once, and so you have to go back and forth with the side-to-side arrows. Let's try the other one, converting into rectangular, 1.616, and the angle is 21.801 degrees. So this line has x coordinates of 1.5, y of 0.6. That's not what it looks like, right? I think that that angle, 21 degrees, it's maybe more like that would be to scale. If it's 21 degrees, then it would make sense now. If the length is 1.5 and the height is only 0.6. Okay. The last thing we're going to look at today is the functions it can do to go between degrees, minutes, and seconds calculations. And if you've ever taken a geography class before, or you'll get into it when you take surveying, coordinate systems are used with GPS to describe locations on the Earth's surface, and sometimes you need to add these together, and it can be a little bit awkward to do it manually, because first you'd have to add the seconds together, and then the combined seconds you add into the minutes, and then you'd add it into the degrees. But this solves all that. But the odd thing about it is that when you're setting up a problem, like if you're adding two different sets together, you push the same button. The button on here that we're going to be using is the degree, and then it's got the first comma is meant to indicate minutes, and the second group of two commas is meant to indicate seconds. And so it shows all three of the values that you type in. It puts the degree sign after them. But don't be thrown off by that. So let's try that. First of all, just the 2 degrees, 20 minutes, and 30 seconds added to 39 minutes and 30 seconds. All right, so 2 degrees, 20 minutes, and even though it's showing the degree sign, it knows that it's minutes by virtue of where it is in the when you've typed it in, like its position defines it. So 30 seconds plus 0 degrees, because if we're just doing 39 minutes and 30 seconds, we have to tell it 0 degrees. Otherwise, it would think the first number that we typed in was the degrees. So we need to put 0 degrees, 39 minutes, and 30 seconds. All right, so we've added those together, and it calculates it as 3 degrees, 0 minutes, and 0 seconds. All right, so try that with these 2 additional calculations here. Verify that you can get it to both add and subtract. By the way, you do not have to type in the leading 0. So here where you're adding 13 degrees, 5 minutes, you can type in 0, 5, but you don't necessarily have to. Okay, so for the addition, we would do 33 degrees, 45 minutes, 25 seconds, and add that to 13 degrees, 5 minutes, 44 seconds, and it gives us the expected answer. And the same thing, it works also for subtraction. Degrees, minutes, seconds, minus degrees. You do have to put the 0 in as a placeholder. Otherwise, it will get confused by the ordering and give you the wrong answer. So 76, 5, 28. The other thing it's able to do is convert between decimal and sexagesimal. And so right now it's on degrees, minutes, seconds. But if you just push on the S to D button, oh no, that's not it, yeah. S to D button or the degrees, minutes, seconds. Just the degrees, commas, and everything. So this button right now, it would take it to a decimal format, convert it back and forth. If you've ever used Google Earth before, like it's a program where as you move the cursor around at the bottom of the screen, it'll show you the GPS coordinates. And sometimes you'll have a map, like a map from the USGS that's in degrees, minutes, seconds, but the program you're using is showing the decimal format. So this is an easy way to convert between the two. Okay. We have 30 minutes remaining in class for you to get a head start on the homework assignment. You know, the homework assignment isn't due for a little while, but just based on what we've talked about today, you could get through the first page. And remember, this assignment's front and back, so some of the problems are on the back side of the paper. We just take one last look at the announcements to make sure that we're all on the same page with those. The assignment I've handed out, that's not due until Thursday, February 2nd. And you definitely need to have the calculator with you for attendance credit next Tuesday. All right, so the time is yours to work on the homework assignment.